Today we're going to talk about polar coordinates. Here I've got a coordinate plane. As you're well familiar with, we have an x-axis and a y-axis. Now, to get to this point here, I have to go over x and up y. So these are what are known as rectangular coordinates. On this rectangular system, the coordinate pair will be x, comma, y. Notice some vocabulary here. We've got this 0, 0 point, which is known as the origin. And we've got an x-axis and a y-axis. Now, if we were going to McDonald's, we would follow the roads if we had the school's Hummer to go get ourselves a hamburger. We go east on 62 and north on Federal. However, if we were in an emergency situation, our stomachs were rumbling, for example, and we really had to get those hamburgers quickly, we'd want to take the school's helicopter, which is right on the roof, by the way. If I get in that helicopter, I'm not going to foolishly be asking, which roads do I follow? There's two bits of information I want if I'm going to McDonald's and I've got the chopper. I want to know how far do I go and in which direction, because I can hover over that McDonald's and fast rope down right through the center into the kitchen, grab our burgers, up the rope, and back to school without nary even touching a blade down on the ground, or a pontoon, if you will. The two bits of information I want are, how far do I go and in which direction? How far do I go? Well, that's R. And in which direction? Stop me if you've heard this before. We're going to go the positive counterclockwise angle from the positive x-axis. We don't have to keep it counterclockwise. We can go clockwise. Remember, when we go clockwise, the angle will be negative. So let's talk about what the vocabulary of polar form will be. Polar form. Well, this point will now be directed distance, comma, directed angle. R, directed distance, theta, directed angle. Polar form will have this, r theta. The origin will now be known as the pole. So the pole is the new origin. The x-axis is now known as the polar axis. So we've got some new vocabulary there. This is the polar axis. And the y-axis is known as that theta is equal to pi over 2. That's this axis. Theta equals pi over 2. So in red here, we've got the polar axis, the theta equals pi over 2 axis, the pole, and we're interested in theta and r, or r theta. Now, why do we call this y-axis the theta equals pi over 2 axis? Look at these points. Directed distance of 1, angle pi over 2. This angle here is pi over 2, and this directed distance is 1. Now, directed distance of 2, angle pi over 2. This point here, directed distance of 3, angle pi over 2. All of those points are in a line. So the easiest way we can say is, I don't care what the directed distance is. It can change. It can be 5 or 10 or 20 or 1 or 2 or 3. As long as we maintain the directed angle at pi over 2, those points will line up on that axis, a straight line.